Happy E-Day. Today we're going to take a look at our stretches and reflections. And so I want to, kind of like we did on Friday, investigate this a bit. So we start with f of x equals sine of x. So find in simplest form y equals 2 times f of x, which of course means plug this in for f of x. So it's 2 times the sine of x, right? Or just 2 sine x. And in this one, it's 1/2 times the sine of x, right? Again, we put the sine of x in there. So now I want you to use your graphing calculator and to graph all three of these functions. So y1, and then y2, and then y3. So y1, y2, and y3 in your calculator. As you're figuring out what mode you want to be, I do want you to be in radian mode. We'll talk about this more next trimester, and we really are going to graph these well next trimester, but I just want you to use this function. It's a really nice visual of what the stretch is going to look like. If you go to your window, please go ahead and set up your window. Your x is from -7 to 7, and then your y from -3 to 3. All right, so I want that to be your window as you graph, and then record your rough sketch below. Make sure you label each function so you know which one's which. Go ahead and pause and try those in your calculator, please. Now that you've graphed it in your calculator, it looks kind of like this. Shows up. Mine's obviously multicolored. So I have my original sine function in red. My y2 is this blue. And then my y3 is that shorter one. And so I want you to take a moment, and again, I'm going to look at this when we get back. I want to see what your explanation is for what effect does that constant have when I put a p in front of the f of x. So what did it do whenever I said twice this or half that? So go ahead and take a few minutes and give me your response right here of what that does. So go ahead and pause the video again. Hopefully we notice quite a few things, right? I'm hoping that we notice not only that I have a taller graph perhaps whenever I have a bigger number there, like the 2, and a shorter graph when I have that 1/2, but the similarities is also important. Notice that your actual x-intercept